In this session I will talk about magnetic force and magnetic field. With that you can do things like this and a lot of other stuff. But before we go into Blender, we can just go to some Google pages. Google magnetic field and you will get pages similar to this. Why I would like you to do this is because what we are talking about is particle movement similar to magnetic fields that you can see here. There are a lot of ways to create magnetic fields. Even the Earth have a magnetic field, as you can see. And the important thing to know is that in Blender we need some charge on the particles to make something happen. So that means in reality that we need movement, but also the direction of the particles have importance. So if you look at images, you can see that it behaves in different ways depending on the shape of the emitter or the source. All this is easy to show in Blender, thus I go right into Blender now. And what I have here is my default setting, so it's a plane, a camera and a bit of light. I just move the camera away so we don't have it there, and I start by creating a particle source. In this case it will be a UV sphere, so Shift A, Mesh, a UV sphere. I move it using GX, then I select the plane, which will be the emitter. I go to Particle Properties, I press the plus sign, setting frame start and end to 1, so all particles starts from beginning. A lifetime I will put to 1000, and then I know that they will survive the animation. I will not change anything in source, but I will set normal to 0 in the velocity. And that is because no movement occurs in the start then. And then in field weight I change gravity to 0. And if I now run the animation, nothing happens. So now we can add a UV sphere. In Render As, select Object, and then in Instance Object, select Sphere. When we've done that, all the particles are UV sphere, but if I run the animation, still nothing happens, because we need a force as well. To add force, Shift A, force field, and in this case, magnetic. When it's in, I run the animation again, but still nothing. And that is because we need movement. Let's select the emitter and go back to the particle properties. In the velocity, increase the value of normal. It can be rather low, so put it around 0.2 or something, just so we have some value. Then we run the animation again, and now you can see the initial movement make things happen. And now it's following the magnetic field from the force. I can change the end frame of the animation so you can see more of the things happening here. As you can see, it's a smooth movement of all particles since we had some initial speed. And since speed is so important, we often use magnetic together with other forces like wind or vortex. And vortex is really nice together with magnetic. The animation continues now, and you can see how the particles are moving really high up. But now let's add some vortex to this. Stop the animation, I set normal to 0 again. And now I add another force, the vortex force. So Shift A, and then I press force field and go to vortex. And when I have that, I move it up using GZ. And now I run the animation and you can see that the vortex is working. However, the magnetic force doesn't do much. It exists though, so let's do a test. I turn off the magnetic field, I go to physics property and I set the strength to 0. And then I run the animation again, and you can see now that the vortex moves the particles, but now everything is flat. Last time we had the center of all the particles was moving a bit up. but that doesn't happen now when we have deactivated the magnetic force. In the magnetic force, the direction is very important, not just the strength and movement. So what we can do is let's change the direction of the vortex and see what happens. So we select it, and then I rotate it 90 degrees, pressing RX90, and run my animation again. And you can see a completely different pattern. Vortex, it's not just that the particles are moving in vortex direction, but they're also bending a lot more. Another thing is that it works like a mirror. So everything that is happening on that side, it will also happen on the other side. And that we can use for many nice things later on. So this is how it works right now. A final test is to remove the magnetic force now when we turn the vortex. I set the strength to 0 and run the animation. And now all the particles follow the vortex, but you can't see any bending of them at all. So we can conclude that the bending and distortion of the particles is caused by the magnetic force. So now it's time to put everything together. And we start by selecting the magnetic force and set the strength to 1. Then select the emitter, and I will change one thing for the particles. So go to the particle properties and go down to the physics and check multiply mass with size. This will make the particles react a little easier to gentle strength on the force. And you can see it when I run the animation now. Now we need some fine tuning, so select the magnetic force in the middle of the plane. Then after you have selected it, you move it up using GZ. So now when we have a vortex force, a magnetic force, and then we also have the emitter in the end here. So if I run the animation, it looks like this. It moves to the center. And as you remember from the vortex session, to avoid that all particles are collected in the very center, we can just change a few parameters in the vortex force. So go to physics properties and change inflow to a negative value. And I would try like minus 1.1 or something like that. I think it would be a good start. And then I run the animation again, and all the particles are thrown away from the center. And that is because we need a fall off as well, as we used in the vortex session. So set the power of the vortex to something like 0.9 and run the animation. And now the both forces start to work together and we get some nice pattern. That pattern can now be fine-tuned by changing the fall off. Try as an example to decrease it to like 0.6, and now when we have some balance between the forces, you can try and move the magnetic force. So right now before we move it, we have this mirror effect, as you can see, and I can see that we have a little high strength on the magnetic, so I decrease it before I move the force. Select magnetic, strength down to around 0.7, and now I have a good pattern here, and the movement looks symmetrical, and you can see how it follows the vortex, but still has influence from the magnetic force. Okay, let's move it, we'll see what happens. So move it, and suddenly we have a different pattern. Try some different position, and see how the particle follows the magnetic force. Now you see how we can create fantastic pattern using the magnetic force together with some other force like this. So in our example here, you can clearly see how it goes through the magnetic force and then follows the flow from the vortex force. And now we change the strength again. This is where you feel the changes. I think we start with the vortex. So stop the animation. And I then select the vortex, and increase the strength around 1.7 or something like that. Run the animation again, and it's much faster than before. Let's increase it even more, 2.2. Now it's really fast, but Vortex takes over a lot and you get more of a line. However, you can see how they cooperate, because if I move the vortex like this, the particle gets a lesser area since the forces are closer to each other. Okay, so now I think you get a hang of it. And this is how you can work with the magnetic field. So here we have used a vortex to get all this nice pattern, but you can of course use other forces as well, as long as they create movement. The best forces are those with constant flow. So if we take vortex, then besides vortex we have like a wind or harmonic that provides that type of movement. So all these are really good to work with. Okay, now let's leave this scene. Instead, let us take a closer look on how I built the introduction. So go and open the file called Force Magnetic. And here you have my bird created by the particles. How close to bird the silhouette is depends of course of the camera view. So how did I do it? I used the same as before, so the bird have a vortex force field and then below is a magnetic force. And that will be creating a big force field, and then I can get this bird animation in. The illusion of a bird taking off from the ground I do by just let the plane fall. Then it seems like the bird is going up, so it's a little bit of a cheat. Then I do the movement of the wings by animating the strength of the force. So I select the magnetic force, and then you will see the animation as keyframes here below. Now let's go into the physics properties, and here you can see small dots to the right of the parameters. If a white dot exists, it means that that parameter can be animated. That gives a lot of new opportunities to tweak the particles during the animation. And one way is to play with the strength, as I do here. That makes all really dynamic. It's very easy to use these dots. All you do is place the animation on the desired frame, write the value you want to have as a keyframe, and then just press the dot. And as soon as you do that, you have a new keyframe with desired value in your animation. So really, that is all you have to do. If you want many keyframes, then just repeat. So move, right, and press a dot. So it's very easy to do that animation and make everything happen like I did in a bird. So by changing so, we get more or less strength in my animation. I make those wings flaps that you could see in the clip in the beginning. So now you know a little bit more on how to use magnetic force, and then I will show the next force in the next session. So see you there, and I only say bye for now and see you later.